We're going to have some left and right transformations with the cosine of x. So when you do the cosine of x, it's just like the sine of x. You're going to set this parentheses equal to 0 and 2 pi. All right, so let's identify the pieces of the equation. First thing, -3. Take the absolute value of -3, and it is 3. So there's your amplitude. Here is your b. So b is 2 pi. So your period is going to be 2 pi over b. So your period is 1 radian. Translations, yes, we have a parentheses here. So we're going to be shifting left to right. Is there a reflection? Yes. So instead of starting at the top of the amplitude, you're going to start at the bottom of the amplitude. I've thrown a lot of things at you here to get you going. So now we're going to take this purple circle and set it equal to 0 and 2 pi. So 2 pi x plus 4 pi equals 0. And 2 pi x plus 4 pi equals 2 pi. And what we do is we solve those both for x. So I'm going to subtract 4 pi from both sides. Then I'm going to divide both sides by x. So -4 pi divided by 2 pi. The pi's cancel out. And you get x equals -2 radians. Come over to the second equation. Subtract 4 pi. Leave the left-hand side alone for a minute. 2 pi minus 4 pi is -2 pi. Then divide both sides by x. So -2 pi are divided by 2 pi. And you get x equals, pi's cancel. -2 divided by +2 is -1. So you get -1 radians. All right. So where we start at on the x-axis, here's -2 radians. That's our left end point. And we're going to stop at -1 radians. Our amplitude is 3. So we're going to go up 1, 2, 3, and down 1, 2, 3. And then here is 0. We split the left and the right end point up into 4 equal parts. So I split it in half. I'm at -1.5. Split it in half again. I'm at -1.25 and -1.75. Sorry, I got a little scrunched there. Now, since we had a reflection, normally we start at the top of the amplitude, but we're going to start at the bottom of the amplitude at our starting point of -2 radians. Then we go to our middle. Then we go to our top. We go back to our middle, and then back to the bottom. So here's what one revolution looks like. Narrow and tall.